This is thumb rule for depth of boring. So this is the depth of the foundation. D is the depth of foundation, and I consider Z is the depth of exploration. So how it is a thumb rule just to find out how I should decide what should be the Z. So I will see that at Z there will be a earth pressure. So this triangle what you are seeing, this triangle is the because of the earth pressure. So it has been mentioned effective overburden pressure. It is sigma 0 dash, and when I put a foundation here, it exerts a pressure, means with depth the pressure will get distributed, because the pressure will get distributed by bulbs, means by consider both side 45 degree, it will go down. So lower the area, the deeper is the area, the lower is the pressure because of this foundation. So this will be almost an inverted triangle or a triangle, or you can say actually it will go like a curve. It will go down like a curve. So this is the vertical stress due to curvature. If I calculate both them together, and sigma delta sigma is the increase in vertical stress due to load, or this is the load at Z height when the foundation has been kept at D depth. Foundation has been kept at D depth, and at a Z depth the pressure due to foundation is delta sigma, and the original effective overburden pressure is delta 0. Then Z should be approximately or less than 10% of the effective overburden pressure. This is a thumb rule criteria for deciding how deep I have to take a bore and find out whether this pressure, this area is sufficient to take both the load together at this location or not. In case it is not, you find that it is not possible to do, then you have to go further deep. And for the weaker soil, sometimes we keep this only 5% of this, because the weaker soil, the capacity to take load remains low. Generally 5% of sigma 0 dash for compressible strata. So I have mentioned that RDSO specification G004 is very good and has very methodically decided what will be the extent of taking bore holes and what will be the extent of going underground, or what should be the depth of the excavation, what should be the sample size. Everything has been mentioned. So just to show that reading these documents will make you knowledgeable, and your knowledge to deal any problem and for deal any project will be better. You will be able to take a better decision. So just for your knowledge, I am showing this slide. So here you see that bore holes in preliminary survey, bore holes has to be made at every 500 meter or change of soil strata. Depth of boring 1.5 to 2 meter depth below the existing ground level. Because we are making foundation, it is not for the bridge. It is not for a structure. It is for only for formation. In case of 4 meter high or higher embankment or problematic strata, boring up to the twice the height of the embankment. Means if I have to build a 4 meter high embankment, I have to go below the existing ground 8 meter below, so that I am oversure that my embankment is not going to cause overpressure over the subsoil, and the subsoil will not fail. even during rains and when the water table is high. So, and for final location survey, we have to take at every 200 to 300 meters, just the double of the bore log what we have done during the preliminary survey. And depth of boring almost remains the same, 1.5 meter depth or change of strata, or if you find that up to 1.5 meter the soil is very weak, then you may have to go deeper. How deep is that location, so that you take precautionary measures to strengthen the subsoil, do subsoil strengthening, which is a completely different subject, but has been mentioned in this report. And Unison is taking different classes and webinar courses for treating the formation, how to make the formation, how to tackle the problems in the existing problems that you can attend. Or even by your study of this railway formation report of G04, you will get the answer. Then this is when a board log is made by your agency, what properties or what are the items they are supposed to write on your board log and give you those details has been mentioned in IS 1892, which is applicable for us also. So site plan and selection along with following information should be given. It is name of agency, location with map and plan reference, pit number, reduced level of ground surface or other reference point, dates started and completed, who has supervised it, scales of plans and sections, dimensions, types of seating and other materials of stabilization, advancing the exploration such as by hand tools, blasting, boring. How they have done this entire structure should be mentioned, because that will give you a rough guideline that during construction of your foundation, what precautions you have to take so that you can, or what action you have to, what materials you will be required, so that you can plan the entire work in advance and will not get caught at the site that now something has started collapsing, so your entire works get stopped till time the further material of sheeting or shuttering are arranged. So these have to be mentioned. General description of a strata, that is, for this we are doing this excavation and doing the exploration. The level at which the subsoil water is met with, inflow of water, methods of controlling the water, required capacity of pumps. So for this bore log, if something is happening and this much capacity or this much method or this much inflow of water we are facing, so for the higher or actual construction, what difficulty you are going to face, you will know beforehand. Position and altitude of contacts, faults, strong joints, slick sides, etc. When there is such geographical conditions are met with, and to deal with them, you have to take the help of the expert geologist, and as with our limited knowledge for the functioning of these, our decision will not be very appropriate for such kind of location or foundations. So you must refer some geologist. Dip and strike of bedding and of cleavage, same thing what I have mentioned earlier. Any other information and remarks. So I will show you a boring record. So this is a sample boring record. What has been not mentioned here should have been mentioned, and these are the soil classification, and these are the location where the samples have been taken. This has been mentioned. soil classification, sampling, depth of bore. Here they have not mentioned the strength. The next borehole, log hole, I will show you. This is the a project site borehole of Guwahati Jogigopa Bridge. So you say method of boring mentioned, rotary, depth of boring 13.76 meter, water table has been met at 35.88 meter. This is all RL. Borehole PH1 location has been mentioned, date when started, date of completion has been mentioned. Then from here to up to this location, they have mentioned the depth. So this is at zero depth. This is the water level. Here this is the ground level. Sorry, this is the ground level, and they have taken these samples like this. Here water table is much below than this. The water table is we have not met, but here we have met the water table because we have gone up to 55 meter, and here the water table is at 35.75 meter. So as whatever we have met, whatever strata we have met, we have mentioned those strata, at what reduced level these have been met, that depth has been mentioned. Based on this ground, considering that ground as RL of ground level is, sorry, I misread it. RL of ground level is 35.88 meter, and at that location the water table is also there. And considering 35.88 as zero, they have marked the ground below. Whatever is the soil strata has been mentioned and marked here. What is the thickness of that strata has been mentioned. Then at what location they have done the SPT value has been mentioned here. On the almost on the same location or just nearby location, they have done the dynamic cone penetration test also. If you remember, dynamic cone penetration test for 300 mm, whatever is the blows, number of blows are required, that are counted, and that is converted into SPT value by the formula which has been given by the Roorkee, Central Building Research Institute, Roorkee. And SPT value, we are getting the whatever the number of blows for 450 mm driving, out of which the first 150 mm blow, for the first 150 mm blow is not counted because it is considered as a seating, and the remaining 300 for the driving, for the remaining 300 mm depth, the number of blows required is counted, that is considered as a SPT value with correction applied, 2 corrections applied depending on the site. So these are the SPT value. Then these are the samples. So these are the samples. D means that is disturbed sample. UD means they have taken the undisturbed samples. And what are the number of samples taken, that has also been mentioned. And at what depth, to what depth they have taken, it has been mentioned. So you will find that the SPT values at 1.5 is 4. Then it has been mentioned that every 45 centimeter, at every 1.5 meter, you take the SPT value is taken at every 1.5 meter depth. So we had to take 1.5 meter, we have taken the first one. So I have to take on 3 meter the next one. But it has also to be taken where there is a change of a strata. So at 2.4 meter there is a change of a strata. So you will find that we have, instead of 3, it has been taken at 2.5. Instead of 2.4, they have started taking at 2.5. 5 to 10 centimeter difference. In classroom, it appears that it is 10 centimeter below, but the soil stratas or the soil layers are not like a pencil line. It is just a mix-up of soil, which will be blackish sand and grayish fine sand. It will be a type of mix-up. So 5-10 centimeter plus minus is a minor difference. So now they have taken at 2.5 meter. So it will go further 45 centimeter down. So it has gone 2.95. Then next, after 1.5 meter, it becomes 4. Now they have taken at 4. It will go further for our experiment will be for the further 45 centimeter. So it is 4 to 4.5. Then after 1.5, it is at 5.5. So again 5.5 to this 5.95. So you see that by the same series it is going down. And for if the number of blows increases 100 for this 300 mm, then the SPT is considered that it is refusing. But here you will find it has not exceeded 100, so even not 50. So these SPT values are valid. Now I will explain you DCP values. So this is the dynamic cone penetration test. So you see it is 9. The same SPT value is coming on the nearby location as 11 and the DCP value is coming as 9. Similarly here DCP value is coming at 10 and SPT value is coming as 8. So you have to take a very judicious decision whether to take 10 or 8 or 9 or 11 or a combination of this means 10. That will depend on your engineering judgment. So, but because these values are nearby, so we are confirmed that our DCP and SPT value experiments or what we have encountered is correct. Now DCP is a direct one, means DCP is a direct cone, the dynamic cone penetration test. It is penetrating throughout the length. So you will get the value at any location wherever you want. But wherever you want a location, you have to take a 300 meter slice and every slice will be of 100 mm. So for any location, if you want, you have to take a 300 meter slice and the number of blows to convert it into the SPT value. So here you say that at 9, at depth 3 they have chosen. So they are taking 3, but it will represent a value from 3 to 3.6. Similarly, they have taken it as 4.5. Generally, you will find that they have taken it very nearby so that to find out whether the DCP value and the SPT values are correlating or matching with each other or not. So it is 4.5. Again, it will go by 0.3. Here it is 5.5 to 5.95 SPT value. So from 6 they have started, it will go up to 6.3. Similarly 7.5 to 7.8. So this is explained. And the last is DCP is more than 50. What I have taught you that if for any 300 meter slice, it is more than 35 blow, then it has been considered that it is a refusal. So as the DCP has started giving problem, means for the 300 from 13.5 to 13.76, it could not go to 13.8. And the number of blows required was more than 50. So it is considered as a refusal. So this value 50 will not be converted into the SPT value. Therefore, this DCP is not reliable, and there is a very large difference between 38 and 50. So this is the position of, and this is how the area is depicted, or how the borehole details are given to you. And these samples are given, disturbed or undisturbed samples are packed and handed over to you for the laboratory test, or if the same agency has to do the laboratory test, they will do the laboratory test and will keep a small portion also for reference for your visual examination, because when they will give you the test, they will give you a box where the samples have been kept. So even at the later stage, you can find out the result and can see the sample that at what samples have been tested and what results you are getting. So you can see a small portion or a sample of samples, you can say, you will get on a very big box. So now we will come to the location that for different, basically the soils are of two type of cohesionless soil and cohesive soil. So the tests which are the mechanical properties which are the properties which are required and the behavior are quite different. So what are the properties which we take and what are the tests which we do for the cohesionless soils? It is grain size analysis, liquid limit and plastic limit, specific gravity, shear strength, direct shear, unconfined compression test or triaxial shear test, permeability test if dewatering is required. Generally, cohesionless triaxial shear tests are not needed. Even with the direct shear test, you will get the value. Then field dose test is plate load test, standard penetration test, dynamic cone penetration test, and static cone penetration test. Static cone penetration test, I reiterate that it is not very common, requires elaborate structure, but it is a better test because it gives us the penetration resistance and the skin friction resistance also. So where you are designing for a skin friction file, it is better to do the static cone penetration test, even by spending more time and spending more money on this occasion, because then you will get a better result and the friction files can be designed more economically and more efficiently. Then this the top black strip is disturbing me. I don't know how to remove that. Okay, now it is. So this is for the cohesive soil. So this is the lab test, same grain size analysis, liquid limit and plastic limit, a specific gravity, a strength parameter, direct shear, unconfined compression test, triaxial shear test. Mostly we have to go for this triaxial shear test because the direct shear test, the results which we get are very on lower side, means on a safer side, but our design will be highly uneconomical. Permeability test and consolidation test. And field test are plate load test, standard penetration test, dynamic cone penetration test, static cone penetration test, all with the riders that in field test, the cohesive soil, the test mentioned in 1 and 2 are not very reliable. It gives only an indication, but you have to finally go for the lab test. And vein shear test for soft or cohesive soil. This is the only reliable test in field for the cohesive soil. At last, I am giving you again only a snapshot of the index for the which has been mentioned in code IS 1892. This code also I will share with the course material, or you can download it from the internet and can refer to it. It says that at what location, and for the now everything after telling that you have to use your engineering judgment, you have to use your practical experience, you have to see and ask the other people who are more experienced working on that location, that what type of test is required, how depth I have to go. So just to give you a guideline and summarize the entire position, they have given you, it is quite a big appendix, which shows that for which type of survey or for which type of work and how much detail do you want for that, what type of exploration you have to do. So this is a small snap. The same thing has been given in a full screen in the next slide. Like if you are doing a reconnaissance survey, then if there is a alluvial deposits, weathered and fissured rock, buried channels and groundwater, you can take the electrical resistivity test. You can also take seismic refraction test. Then soundings means these are the geophysical type. This is the sounding. This is the standard penetration test. It is good for non-cohesive soil. Static cone penetration test, primarily used in cohesive soil. So standard penetration test is better for non-cohesive soil, and static cone penetration test is used in cohesive soil. And what is the method has also been described in short, and for which you can refer the same code you can refer, and they have also mentioned that how you will find out the detailed code is there, so that detailed code has also been mentioned. Similarly, dynamic cone penetration test is also primarily used in cohesive soils. So cone penetrometer test has been mentioned. Similarly, for other, how you will use handover, where you will use simplified mud boring, where you will use vast boring, soft to stiff cohesive soils and fine sand except gravel and boulder, where you will use rotary drilling, rocks, fissured rock and all soils except cobbles and boulders. So every type of method, what you have to use, what type of formation you are expected, where you have to do the boring, you can find out a guideline, that you can roughly point out a guideline that which method you have to take, and thereafter you have to use your further judgment and referring to the some codal provisions that how deep you have to go. And this ends my presentation. If you have got any query or problem, then you can ask. And if I'm not missing the name, it was Mr. Salendra, who was from DFCCIL, who has joined late in the last class. Is he there? Are you there? Participants, are my voice? Participants, are you getting my voice?
Yes, sir. Yes,
sir. Yes, sir. Okay. So Mr. Salendra is there, or he's not there? If he's there, he might have responded. Okay. So do you have any question? Then please ask. Or should I close? Then you have to wait. When Kushwaha will be...
sir, I have joined, sir.
Acha, Kushwaha, you are already there.
Yeah, yes,
so
sir.
I am giving you extra time.
Sir, yes, sir.
So, participants, so I should close, and Kushwaha will tell you about the portion which he could not complete it in his presentation.
Yes, sir. 1 minute, please, sir. Sir.
Please.
सर थंब रूल फॉर डेप्थ बोरिंग का जो है, जिसमें डी और जेड का जो रिलेशन सर
हाँ
जो आप बता रहे थे, उसमें
हाँ।
जेड को हम 0 तक डेप्थ तक भी ले जा सकते हैं क्या उसको?
मैं स्लाइड पे फिर आ जाता हूँ। उसको जेड को आप कहाँ तक ले जाने की बात कर रहे हैं?
सिग्मा 0 जो सर उसका जो स्ट्रेस आ रहा है, उसको मैं
हाँ।
जीरो स्ट्रेस को ले जाना चाह रहा हूँ, ऐसा डेप्थ पे ले जाऊँ।
जीरो नहीं हो पाएगा ना।
अच्छा सर।
मतलब जीरो तो इन्फिनिटी पे जाके जीरो होगा।
अच्छा सर।
जीरो तो हो ही नहीं सकेगा ना।
अच्छा अच्छा।
मतलब थ्योरेटिकली वो बहुत कम होता जाएगा, लेकिन जीरो तो कभी नहीं होगा।
अच्छा अच्छा। दिस इज थंब रूल, यानी एक
मतलब अगर ओवरबर्डन प्रेशर कहीं पे 100 kg पर मीटर स्क्वायर है, तो हम ये मानते हैं कि इसका वो 10% और लोड ले सकता है
जी।
मतलब अभी उसमें लोड लेने की कैपेसिटी 10% बाकी है। और अगर वो वीक सॉइल है, तो अगर वो 100 है तो वो 105 तक लोड ले सकता है। तो हम अगर कोई लोड ऊपर से लगाएं तो उस लोकेशन पे 5 kg पर मीटर स्क्वायर से ज्यादा का लोड डिस्ट्रीब्यूशन, वो तो जैसा बनाते हैं 45 डिग्री से जनरली लोड डिस्ट्रीब्यूशन बनाते हैं, तो वहां तक जाते जाते 5 kg पर मीटर स्क्वायर से ज्यादा ना हो।
तो सर इसका
थंब रूल।
जी जी। तो अप टू 5% सर जो सिग्मा जो स्ट्रेस रहेगा, तो मतलब डी का क्या रिलेशन में जेड रहेगा सर?
अच्छा, फिर बताता हूँ, फिर मैं वहां पे आता हूँ तब आपको समझाता हूँ। हाँ, यहीं पे हम लोग।
यस सर।
ये
और जेड का अप टू
ये जो डी है
कितना रिलेशन रहेगा, मतलब क्या
है
सर?
ये देखिए, ये डेप्थ आ गया, तो अब इस डेप्थ के नीचे ही हमारा लोड लगेगा इस डी से।
जो बल्ब शेप का रहेगा सर?
मतलब बल्ब शेप नहीं, एक्चुअली मतलब जब हम लोग काम करते हैं, जब थ्योरेटिकली बनाते हैं, तो इसको हम मानते हैं कि यहाँ से 45 डिग्री एंगल पे ये डिस्पर्स करता है।
यस सर।
मतलब ये जो लाइन बनेगी, मैं बना
जी
के
जी
दिखाता हूं।
दिखाई दे रहा है सर, विजिबल है सर।
हाँ, ये जो लाइन है ना, ये यहाँ से 45 डिग्री ऐसे, अब 45 डिग्री ऐसे जाता है। तो अगर मान लीजिए यहाँ पे, अगर मान लीजिए इसको हम एक मान लें, इसको अगर हम लोग 5 मान लें, इस पे 20 kg का लोड लगा दें, तो 20/5 4 kg पर मीटर स्क्वायर यहाँ पे आ गया।
जी
आ गया।
यस
और ये इस जगह पे आ गया। अब जब ये चीज बढ़ते बढ़ते, समझिए ये जो 5 था बढ़ के यहाँ 10 हो गया, ये एरिया 10 आ गया, तो ये ऊपर का जो 20 का लोड था वो 10 से डिवाइड होगा, तो यहाँ पे 4 kg था, ये चूंकि 5 स्क्वायर मीटर था, ये अगर 20 स्क्वायर मीटर हो गया तो यहाँ पे 2 स्क्वायर मीटर हो जाएगा। तो ये धीरे धीरे घट रहा है, लेकिन इस तरह का रोड डिस्ट्रीब्यूशन के चलते ये कर्व मतलब रियल एक्चुअल में ऐसा होगा, और हम उसको ऐसा मान रहे हैं। मतलब ये कर्व नहीं है, मैं स्ट्रेट लाइन नहीं खींच पाया हूँ, इसलिए हुआ है। ये जैसे इधर का ट्रायंगल आ रहा है, वैसे हम इसको ऐसे ट्रायंगल से मान रहे हैं। तो ये अगर दिस इज रोज सिग्मा डैश 0 डैश इज द इफेक्टिव ओवरबर्डन प्रेशर, तो इतना प्रेशर तो ये जगह ले ही रहा है। दिस location is already taking this much load.
Yes sir.
So only 10% extra load, I am assuming that it will, my structure will cause extra load only 10%. So they have got safe capacity, ये अपने roughly ऐसा मानते हैं।
Yes sir.
ठीक है।
इसका सर रिलेशन क्या रहेगा डी और जेड में, मतलब कितना डेप्थ का कुछ है?
जेड में कोई रिलेशन नहीं है। डी जो है, डी का जेड से कोई रिलेशन नहीं है।
अच्छा सर।
मतलब हम अगर इस डेप्थ के बजाय इसको और नीचे लगाते
सर, उसको हम मतलब डी से 1.5 डी या 2 डी ऐसे
1.5 डी पे कर दीजिएगा, तब समझिए कि यहाँ पे प्रेशर बढ़ जाएगा। मान लीजिए कि हम फाउंडेशन को यहाँ पे रखते हैं, फाउंडेशन को हम यहाँ पे रख देते हैं। तब तो ये 5 kg था, ये 20 kg का लोड था,
यस
ये 5 स्क्वायर मीटर था, तो यहाँ पे 4 kg आ गया। बात समझे आप?
जी जी
तब तो अगर इसको हम डीप लेके जा रहे हैं तो मेरा फाउंडेशन का प्रेशर यहाँ पे बढ़ रहा है। जो प्रेशर 4 kg यहाँ मिल रहा था वो 4 kg यहाँ मिलेगा।
सर।
दिस इज द ग्राफ। ये ग्राफ सिर्फ जो समझिए, ये समझिए लोड के चलते हैं। ये एक अलग ग्राफ है, लोड का ग्राफ अलग है, लोड का ग्राफ ये अलग है। जैसे जैसे ये डीप होता जाएगा ये ग्राफ भी डीप होता चला जाएगा। और ये एक एक्चुअल ओवरबर्डन प्रेशर का ग्राफ है और ये दोनों ग्राफ को कंबाइन कर रहे हैं।
जी जी।
और
तो इसकी अपेक्षा मतलब कब है?
और देखने में ये आया है, प्रैक्टिकल एक्सपीरियंस ये है कि जैसे जैसे हम डीप जाते हैं नीचे वाले अर्थ का जो कैपेसिटी होता है जनरली वो हायर कैपेसिटी होता है, मतलब उस पे आप ज्यादा लोड डाल सकते हैं। इसलिए अगर स्ट्रक्चर ऊपर अनसेफ होता है तो हम स्ट्रक्चर को नीचे लेके जाते हैं।